Welcome, everyone. Today, we're kicking off our lecture series on AWS, or Amazon Web Services. This is Lecture 3, and I'm excited to have you all here. The title of our session is ComputEra, which will guide us through some key concepts and practical insights. In this presentation, we'll cover the fundamentals of AWS, explore its core services, and look at how it's transforming the way we handle computing tasks. So, let's get started and make this session informative and engaging. A hybrid cloud is an integrated computing environment that combines a private cloud, which is dedicated infrastructure, with one or more public clouds. This setup allows data and applications to be shared seamlessly between them. But it's important to understand that this isn't just about using both environments separately. Instead, it's about orchestrating them as a single, flexible unit. This integration provides several key benefits. First, workload portability means you can move applications and data smoothly based on your needs, whether that's cost considerations, performance requirements, or compliance. For example, during seasonal traffic spikes, you can cloud burst from your private cloud to a public cloud, ensuring your systems handle the load without a hitch. Next is strategic data placement. Sensitive data can stay secure on your private cloud on-premises, while less critical data or public-facing applications can be hosted cost-effectively in the public cloud. This approach helps optimize both security and costs. Then there's unified governance. You can set up secure, third-party access using a single set of identity and access management policies that apply across both environments. This ensures consistent security and simplifies management. Major cloud providers like Microsoft Azure, with tools such as Azure Arc and Azure Stack, AWS Outposts, and Google Anthos, offer the frameworks and tools needed to build, manage, and migrate workloads across this hybrid environment smoothly. In essence, a hybrid cloud combines the strengths of both private and public clouds, giving organizations the flexibility to optimize performance, security, and costs, all within a unified, orchestrated environment. Now, let's talk about unified management in a hybrid cloud environment. A truly effective hybrid cloud relies on orchestration and management tools like Azure Arc, AWS Outposts, or Google Anthos. These tools give us a single pane of glass, meaning we can manage resources across both private and public environments seamlessly. This setup ensures that policies, security measures, and compliance standards are enforced consistently everywhere, simplifying governance and reducing complexity. Next, we need to consider strategic workload placement. It's not just about dividing resources equally or arbitrarily. Instead, it's about placing each workload in the environment that best suits its specific needs. For mission-critical applications, sensitive data, or legacy systems that are hard to migrate, a private cloud makes the most sense. These are systems where security and compliance are paramount, like GDPR or HIPAA requirements. On the other hand, for scalable web applications, big data analytics, disaster recovery, or development and testing environments, public cloud offers rapid provisioning and cost-efficient scaling. This flexibility allows organizations to respond quickly to changing demands without over-investing in infrastructure. In essence, hybrid cloud isn't just a mix of environments. It's a strategic approach to optimize workload placement, leveraging the strengths of both private and public clouds. This approach aligns perfectly with our overall goal of agility, security, and cost-effectiveness in modern IT. Let's talk about cloud bursting first. This is really a game-changing feature. During times of peak demand, like a retail website during Black Friday, an application that runs mainly in the private cloud can burst into the public cloud. This means it can access additional compute resources seamlessly, without any disruption. The key benefit here is ensuring your performance stays solid, all without the need to maintain expensive, idle hardware on site. Next, let's look at enhanced disaster recovery and backup. The public cloud acts as a perfect, geographically distant recovery site for your private cloud. You can replicate your data and applications to the cloud, creating a robust disaster recovery plan. And the best part, it's often more cost-effective than maintaining a second physical data center. This approach gives you peace of mind, knowing your critical systems are protected and quickly recoverable, no matter what happens. Finally, there's phased migration. As we've seen with Azure, adopting a hybrid cloud model is a strategic step in digital transformation. It allows organizations to migrate applications gradually, at their own pace. This way, you can modernize your systems incrementally instead of trying to do everything all at once with a disruptive lift-hand shift. It's a flexible approach that reduces risk and helps ensure a smoother transition to the cloud. So let's look at a small business example, Bella's Bakery. Bella owns a cozy shop and also takes custom cake orders through her website. Now, she faces a common challenge. Her old computer in the back office runs her Order Master software, which stores all her recipes, customer orders, and sensitive supplier pricing. Her website is pretty basic and hosted by a cheap shared hosting service. During busy holiday seasons, her website gets overwhelmed, crashes, and she loses sales, something every business wants to avoid. This is where the hybrid cloud solution comes in. First, Bella keeps her critical data, her recipes and customer orders, on a new, more powerful computer right in her bakery. This setup is her private cloud. It's secure, she controls everything, and her recipes stay confidential. Second, she moves her website to a public cloud service, like Microsoft Azure or AWS. This way, her website benefits from the cloud's scalability. And third, she connects the public cloud website securely to her on-premises system. So, when a new order comes through the website, that data is instantly sent over the internet and saved directly on her bakery's computer. The main benefit here is handling traffic spikes. During the holiday rush, the public cloud can automatically scale up to manage all the extra visitors without crashing, ensuring Bella never misses an order again. Plus, her sensitive business data doesn't stay on a public server forever. It remains safely stored on her own machine, keeping her information secure. And finally, cost-wise, she only pays for the extra cloud resources during the busy seasons. The rest of the year, her costs stay low. So this hybrid cloud setup really helps Bella run her bakery more smoothly, securely, and efficiently, especially during those critical high-traffic times. A community cloud is a collaborative cloud computing infrastructure that is shared by several organizations within a specific community, all of whom have common concerns such as security, compliance, or a shared mission. It's a multi-tenant architecture, meaning multiple tenants, or organizations, share the same environment, but this setup is exclusive to a closed group rather than the general public. The core idea here is that it strikes a balance between the control you get with a private cloud and the accessibility of a public cloud. It's designed specifically for collaboration on a shared platform while still addressing the unique needs of the group involved. One of the key points is that it's shared by a defined community. That means the user base is limited to a specific, predefined group of organizations. For example, banks and financial institutions that need to adhere to the same regulations, like PCI DSS, can use a community cloud to ensure compliance across the board. Similarly, government agencies within a country or state that need to share data securely can benefit from this setup. Research institutions and universities collaborating on a specific project, such as CERN, also fall into this category. And healthcare providers within a network who need to share patient data securely under HIPAA rules can use a community cloud as well. So overall, a community cloud is about creating a secure, shared environment tailored to the needs of a specific group, fostering collaboration while maintaining control and compliance. Now, let's look at some of the common goals and requirements that member organizations typically share when working together in a community cloud environment. First, regulatory compliance needs are crucial. All members must adhere to the same strict legal frameworks, ensuring that everyone is on the same page when it comes to legal and regulatory standards. This helps maintain trust and consistency across the board. Next, security policies are a key focus. A unified set of security protocols and access controls is enforced, which means everyone follows the same rules for protecting data and resources. This consistency reduces vulnerabilities and makes security more manageable for the entire community. Finally, many organizations work towards shared mission-critical objectives. Whether it's scientific discovery, public service, or other important goals, these common aims help align efforts and foster collaboration. Now, moving on to management models, this is about how the cloud is owned and operated within the community. One option is jointly managed, where member organizations come together to oversee and manage the cloud collectively. This promotes shared responsibility and cooperation. Alternatively, some communities opt for third-party management. In this case, a specialized external provider is contracted to build and operate the cloud, bringing in expertise and potentially streamlining operations. And then there's hybrid management, where one leading organization takes charge on behalf of the others. This approach can provide clear leadership while still involving multiple stakeholders. Overall, understanding these models helps us see how different communities tailor their cloud management to best fit their needs and structure. Let's take a look at this example from the healthcare industry. Here, we're talking about a regional health alliance that includes 5 hospitals, a dozen clinics, and a research university. The main challenge they face is how to securely share patient records across all these entities to support coordinated care and medical research. Of course, this must be done in strict compliance with HIPAA privacy laws to protect patient information. Their solution is to partner with a cloud provider to create a community cloud. This cloud hosts a shared electronic health record system, or EHR. What this means is that if a patient is treated at one hospital, their records can be accessed seamlessly by a specialist at any other facility within the alliance. This greatly improves care outcomes because providers have immediate access to the complete patient history. Importantly, the entire infrastructure is built to HIPAA specifications. This includes access controls and audit logs that are managed consistently across all members, ensuring privacy and security are maintained at every step. This example highlights how a community cloud can facilitate secure data sharing within a healthcare alliance, ultimately enhancing patient care while adhering to strict privacy regulations. Next lecture topic, virtualization. Today, I want to give you a sneak peek into what we'll be exploring next. We'll dive into virtualization, which is a fundamental concept in modern computing. Basically, virtualization allows us to create multiple virtual machines on a single physical hardware system. This means we can run different operating systems or isolated environments without needing separate physical servers. It's a powerful way to maximize resource utilization and improve efficiency. We'll look at how virtualization forms the backbone of cloud computing and data center management. And we'll discuss the key technologies behind it, like hypervisors and virtual machines. Understanding virtualization is crucial because it connects to many other topics we've covered, like network management and security. So, I'm excited to explore this topic with you next time and see how it shapes the future of IT infrastructure.